Hello dear students, this is a NEET crash course for physics subject for upcoming NEET UG exam 2026. So we are starting from the very basic chapter, that is basic maths. Let's start. So the chapters of basic maths are as follows. The first one is algebra. The second chapter is trigonometry. The third chapter is coordinate geometry. Then we have graphs. There are 3 to 4 graphs which we have to deal. Then differential calculus, most important topic, chapter. And then integral calculus. So these are the chapters which we have to cover for physics. So better you prepare notes. Okay. Now let's start from the today's topic, that is algebra. So this chapter consists of many topics. So first let's have a look at the common formulae which are used in this physics and maths. So these are the very basic formula, that is a plus b whole square, a square plus b square plus 2ab. Second formula, very common, that is a minus b whole square. So this will be a square plus b square minus 2ab. Third formula, that is a plus b cube, a cube plus b cube plus 3ab a plus b, a minus b whole cube, a cube minus b cube minus 3ab a minus b. Then a square minus b square is a plus b a minus b. So take seriously this basic maths lecture, as many students skip this part and find difficulty in solving the physics numericals. You must understand that physics language, the language of physics is maths. So before understanding the language, how can you deal with the subjects? So be prepared and make proper notes of this video lecture. Okay. Now let us have some examples relating to particular this last formula, and this formula is very helpful in finding the squares of numbers, such as, for example, if you wish to find the square of 99 square, so you can this formula to find the square of 99. This can be written as 99 square minus 1 square plus 1 square. Listen, 99 square minus 1 square plus 1. So this is a square minus b square. So this is 99 minus 1. 99 plus 1 and plus 1. This plus 1. So this is 99 minus 1 is 98. 99 plus 1 is 100. So this will be 9800 plus 1. And this is the trick, dear students. The answer is 9801. So this is the trick. How can you use this formula to find a square of 99? Let us have some more examples so that the procedure will be very clear to you. 98 square. So this can be written as 98 square minus 2. So we can write 98 square minus 2 square plus 2 square so that the expression remains unchanged. Now observe this 98 square minus 2 square. This can be used as a formula a square minus b square. So this will be 98 minus 2. 98 plus 2 plus 4. 2 square is 4. So 98 minus 2 is 96. 98 plus 2 is 100. So this will be 96 multiplied by 100 plus 4. So the final answer is 9604. So are you getting how can you use this formula? So this is a sort of trick. For example, you wish to find 97 square. So this can be written as, this is 3 less than 100. So in one bracket, we must have 97 plus 3. So for that, what we do, we subtract 3 square from this 97 square, and to remain the expression as it is, we must add 3 square. This 97 square minus 3 square can be written as 97 minus 3 and 97 plus 3 and plus 9. So 97 minus 3 is 94. 97 plus 3 is 100 plus 9. So this will be 9400 plus 9, that is 9409. So this is a kind of trick you can use for the number 91 to 99. Okay. So let us move to the next topic of this chapter, algebra, that is linear polynomial in two variables. This is very important. Linear polynomial in two variables. So what is polynomial? So any expression like this, ax plus by is equal to c, where x and y are the variables, a, b and c are the constants. So we can understand this polynomial by using this simple question. And the question says that there are two forces acting on the object and the sum of those two forces is 100 Newton. This is given in the question. And the difference of the force is 20 Newton. We have to find the acceleration of the object of mass 6 kg if bigger force is applied on the object, isn't it? So whatever, there are two variables actually, there are two forces acting on the object. Let us suppose the first force is F1 and the second force is F2, and we can assume that F1 is greater than F2. So the final part of the question says that if bigger force is acting on the object, so we must apply F1 of the object if we are considering F1 greater than F2. So the two conditions which are given in the question, the sum of two forces, that is F1 plus F2 is equal to 100, and difference of the forces, that is F1 minus F2 is 20. So this is given in the question. So how can you solve such kinds of questions? So there are two methods which we by using which we can solve such questions. The first method is we have to look at the variables. For example, here f plus f2 comes and in this equation minus f2 comes. Now if we add these two equations, then what happens? This f1 plus f1 becomes 2f1 and f2 minus f2 becomes, they cancel each other, and 100 plus 20 is equal to 120 Newton. So from here we get f1 is equal to 120 by 2, that is 60 Newton. And from any of these two equations we can find the value of f2. Suppose we put the value of f1 in equation number 1. So we will get f1 plus f2, that is 60 plus f2 is equal to 100 Newton. So from here we have f2 is equal to 100 minus 60, that is 40 Newton. So we have found the two forces. F1 is equal to 60, F2 is equal to. Now what is given in the question, that bigger force is applied on the object. So mass of the object is 6 kg. Bigger force is 60 Newton. So as per Newton's second law, acceleration is given by force by mass, that is 60 by 6, and acceleration is equal to 10 meter per second square. So this is how we can find the acceleration of the object. Now the second method which you can use in such kinds of questions where there are two variables and two independent equations are given is, so the second method goes like this. So I am again writing the two equations, that is f1 plus f2 is equal to 100 Newton. So what you do, express the second variable in terms of the first variable. For example, from here we have f2 is equal to 100 minus f1. Let us suppose this is equation number 1. And second equation as per given in the question, that is the difference of the forces is f1 minus f2 is equal to 20 Newton. So substitute the value of f2 from equation 1 in equation 2. Now what we get, this f1 minus, instead of writing f2, write this value, that is 100 minus f1 is equal to 20 Newton. On further solving this, you will get f1 minus minus plus f1. This is 2f1 minus 100 is equal to 20. And finally, you will get 2f1 is equal to 120 Newton and f1 is equal to 60 Newton. Are you getting? So this is also a kind of method where you are substitute the value of the second variable in terms of the first variable, isn't it? So what in maths says that if there are two variables, then to find the values of those variables, two independent equations must be given in the question, and those two independent equations are found in the two independent conditions given in the question. So the number of conditions will give rise to the number of equations, and those number of equations, by using those number of equations, we can find the value of variables. So the summary of this topic is the number of variables must be equal to the number of independent equations or number of independent conditions. Only then you can find the value of the variables. Okay. Now, next topic is quadratic equations. So dear students, any equation of the format ax square plus bx plus c is equal to 0, provided the coefficient of x square must not equal to 0. So any kind of such equation is known as quadratic equations. Now there are many questions in the physics, particularly in the topic of kinematics, that is motion in straight line, motion in plane, and in some questions of force, where you have to deal with the quadratic equations. I mean the condition which are given in the physics numericals, if you convert it into the equation, then it will form a equation like this, and this such kind of equation is known as quadratic equation. So what is the condition of any equation to be quadratic equation is, the first one is a must not equal to 0 and the degree of the equation is equal to 2. Degree is equal to 2. What is degree? That is highest power of x. Highest power of x. Hai? So in quadratic equation, the highest power of x is equal to, isn't it? So there are two methods of solving such kinds of questions. Let us have a look at the examples. Hai? The first method is term. So as the name suggests, we split the middle term such that the product of whatever terms we are getting must be equal to the product of first term and the last term. For example, here the first one is x square and the last term is 50. So the product of first term and the last term is 50 square. That is 50 square. So we have to split this middle term in the way that the two terms which we get after splitting, their product must be equal to 50x square. So minus 15x can be written as like this one, that is minus 12x minus 3x, can be written as minus 11x minus 4x, can be written as minus 10x minus 5x. Now let us check their product. If you multiply this, 12 is a 36, so this will be given as 36x square. This will be 44x square and this will be 50x square. So which product will we choose? This one. Why? Because their product is equal to the 50x square, that is the product of first and last term. So this is the way we use this method. This comes by practice. Okay. Now we solve the question, that is x square minus 10x minus 5x plus 50 is equal to 0. Now by taking x common, this will be x minus 10 minus 5 x minus 10. So we have to take common, as in these two brackets we have the same thing, that is here x minus 10, here x minus 10. So this can be written as, we take x minus 10 as common, so this will be x minus 5 in one bracket and x minus 10 in second bracket. So if you open the bracket, you will get the result, same result. Now what math says, the product of two numbers is 0. It means that either of the two is 0 or the two must be 0. So either x minus 5, so here we can have the two solutions of this equation, that either x minus 1 can be equal to 0 or x minus 10 is equal to 0. So from here we get x is equal to 5 and from here we get x is equal to 10. So we get the two values of x, that is 5 and 10. What does it mean? It means that if you put the value x is equal to 5, then we get the value 0. If we put the value x is equal to 10, then we will get the value 0 of the expression. So these two values, that is x is equal to 5 and 10, are known as roots of the given equation, are known as roots of the equation, roots of the quadratic equation. Now again, if there is power 2, if there is power 2, that is degree 2, then we have two roots, maximum two roots. If there is power 3, then it will become cubic equation, then we have maximum 3 roots. So it depends on the degree of the equation, that is how many roots we get, isn't it? Second method is by using the direct formula, and which is given by, and the formula is x is equal to minus b plus minus root over b square minus 4ac whole divided by 2. So in this equation, so this equation is x square minus 15x plus 50. No? So I am writing this equation again, x square minus 15x plus 50 is equal to 0. So I am writing it in standard form, that is, here it is nothing but it means that the coefficient of x square is 1. So the standard equation is ax square plus bx. So here I am writing plus and minus 15 in one bracket plus 50. Now you can observe that 1 will become a, minus 15 is b, and this 50 is c. So ax square plus bx plus c. Substitute this value in this equation and solve. So x is equal to minus b, that is minus of b, na? So minus b is equal to minus 15 plus minus root over b square minus 15 square minus 4ac 4, here a is 1 and c is 50 whole divided by 2 times a is 1. On further solving, we will get minus 15, minus of minus 15 is plus 15 plus minus root over 15 square is 225 minus 200 whole divided by 2. On further solving, we will get 15 by 2, 15 plus minus root over 225 minus 200 is 25 by 2. So this will be 15 plus minus 5 by 2. So if we get x is equal to 15 plus 5 by 2, 15 plus 5 by 2, and the second value is 15 minus 5 by 2, 15 minus 5 by 2. So x is equal to 20 by 2 and 10 by 2, that is 10 and 5, the two values. So we are getting the same result and it must be the same. Second question is the velocity of any particle is given by 2t square plus 9t minus 5. Find the time at which velocity is 0. So we have to find the time at which velocity is 0. So 2t square plus 9t minus 5. So put this value equal to 0. Now we have to find the time for which velocity is 0. It means that in this equation we have to find the value of t for which this equation becomes equal to 0. Again, this is quadratic equation, so we can use the formula either by splitting the middle term or by direct formula we can solve. So I am solving it by splitting the middle term. So listen, so this can be 2t square plus 9t minus 5 is equal to 0. So the product of first and last term is minus 10t square. So we split the middle term such that their product is also equal to minus 10 square. So this can be split as 2t square plus 10t minus 1t minus 5 is equal to 0. So this is 2t t plus 5 minus 1 t plus 5 is equal to 0. Now you can listen, you can check now, the first term and the last term product is minus 10t square, and the after splitting the 9t you get 10t minus 1t. If you product this 10t into minus 1t, again minus 10t square. So splitting is done right. Now taking common, so these two brackets have the common factor, that is t plus 5, t plus 5. So in the very next step 2t minus 1 can be taken as common, and this is t plus 5 is equal to 0. Now we again have two values, that is 2t minus 1 can be equal to 0 or t plus 5 can be equal to 0. Now if you solve this, you will get t is equal to minus 5, not possible, and a negative. Time negative means you are moving into the past, which is not possible. So we take the positive value. That is, from here we will get t is equal to 1 by 2, that is t is equal to 0.5 second. So the answer is at t is equal to 0.5 second, the velocity of the particle is 0. So we have found the expression. Okay, now let's have one more example. Let us suppose any question like this one: 3x square plus 6 root 3x plus 8 is equal to 0. So again, the first last term and the first term is 8 is a 24 to 24x square. So you can split this middle term. Hai. So how can you split this middle term? 3x square plus this can be written as 6 root 3, that is 4 root 3 plus 2 root 3. Yeah, this can be written as 4 root 3x plus 2 root 3x plus 8 is equal to 0. Let us check. The first term and the last term is 24x square, and after splitting we are getting 4 root 3x and 2 root 3x. Sorry. So multiplying this 4 root 3x multiplied by 2 root 3x. So 4 2s are 8, x square, and root 3 into root 3 is 3. Again you are getting 24x square. So splitting is done. Right. So from here we can take common as, that is root 3x. So from here we can have root 3x plus 4. Hana? Root 3 into root 3 and x into x square. The first term is done, right? Root 3x into 4, that is 4 root 3x square. Here we can take common as 2, such that in the bracket we have root 3x plus 4. Now observe the factors of the two bracket, they are common, so we have done right. So this will be root 3x plus 2 and root 3x plus 4 is equal to 0. Now again we have two values, that is x root 3 plus 2 is equal to 0 and x root 3 plus 4 is equal to 0. From here we are getting x is equal to minus 2 by root 3 and x is equal to minus 4 by root 3. So these are the roots of the given equation. So we have done 3 practice example numericals, example questions of the topic quadratic equation. Let us move to the next topic, that is laws of exponents and surds. A to the power m into a to the power n. First, let us consider the terminology. This a is known as base and m is known as power, or you can say exponent. So here the two terms which are being multiplied have the same base and powers are different. So whenever the base are same, powers can be added. For example, if you write 10 to the power 2 into 10 to the power 3, base is same, so power can be added, 10 to the power 2 plus 3, and this will become 10 to the power 5. Very simple. Second is, suppose a to the power m divided by a to the power n. So base is same, so power will get subtracted. For example, 10 to the power 3 divided by 10 to the power 2 is equal to 10 to the power 3 minus 2 is equal to 10 to the power 1. Again, a to the power n whole power n. So this will be the power to the power gets multiplied a to the power mn. For example, 2 to the power 2 multiplied by 3. So this will become 2 to the power 2 into 3, that is 2 to the power 6. Isn't it? Now, there are, suppose a into b to the power m. So there is multiplication. So this power will get to the both the terms. That is, you can write a to the power m into b to the power m. For example, suppose 10 into 3 multiplied having power 2. So this 2 will come in base 10 as well as in base 2. So you will get 100 into 9, that is 900. Similarly, if you write a divided by m to the power m, so this will be a to the power m divided by b to the power m. For example, 10 divided by 2 to the power 3, it means that 10 to the power 3 divided by 2 to the power 3. So these are the very basic formula. The very last is any number to the power 0 is equal to 1. Whether you write 100 to the power 0, whether any number to the power 0 is equal to 1. So you can take the screenshot, isn't it? Now the next is now if you put a minus sign, that is, suppose you are writing a to the power minus m, it means that it is 1 by a to the power m. or if you write 1 by a to the power minus m, then this will be equal to m. So you are observing that whenever you shift the number from the numerator to denominator, you multiply it by the minus 1. Huh? Here the term is in the numerator, you shift it to the denominator, then the power gets multiplied by minus 1 and become positive. What happened here? The term is in the denominator, you take it, shift it to the numerator, and the power becomes from minus m to plus m. So change the sign of the power if you shift the term from numerator to denominator or vice versa, isn't it? For example, suppose if you are right 10 to the power minus 2, so this is 1 by 10 to the power 2, that is 1 by 100, isn't it? So these are the things. Now let us talk about surds. What is surds? That is root. For example, if I write root a, so this can be written as a to the power 1 by 2. For example, root 16 can be written as 16 to the power 1 by 2. Now this 16 can be written as 4 square power 1 by 2, and this power gets multiplied, 2 into 1 by 2 cancel, and finally we left with 4. So this is the suppose for example if I write cube root a, if I write cube root a, then this will be a to the power 1 by 3. Now for example cube root 64 is, this can be written as 4 into 4 into 4. So this is cube root. So from this 3 times 4 we get only single 4 because it is cube root. Now many questions, for example if you have to solve 8 2 by 3, 8 to the power 2 by 3, so this can be solved as, this 8 can be written as 2 cube, whole power is 2 by 3, and just we have learned that these powers get multiplied, so this is 3 into 2 by 3, this 3 gets cancelled, so we will left with 2 square, and the final answer is 4. So there are more properties. For example, root a into root b is equal to root a into b. Root a divided by root b, root a by b. But many bio students got confused in such root a plus b, they write root a plus b. This is not equal, है ना? So these are the common mistakes done by bio students. So this is not equal. Only the whole root comes whenever there is a sign multiplication or division. In plus minus, this is not equal to this one. Okay. Now next is logarithm. This is very important topic. So what is log? The first of all, log is nothing but a way of expressing exponent or power. Way of expressing power or exponent. So this is log. Suppose if I write 2 to the power 3 is equal to 8. So what are the terms here used? This 2 is base. This 3 is, you can say, power or exponent. And this 8 can be termed as a result. So by using log, we find its value as, listen, we write log base is 2. So here we write base, and after this we write the result, that is 8, and in the right side of this expression we have the power, that is 3. So this is the way we write log. Actually this logarithm is used in physics in some chapters. For example, when you find a thermodynamic work done, so they are in one of the processes, that is you can express the work in the terms of log. And chemistry as well, in finding the hydrogen ion concentration, this logarithm can be used. So by different examples it will be more clear to you, dear students. So let us have some more examples. For example, if I write 4 square is equal to 16. So in terms of log, we can write log base 4, result is 16, and right hand side, we will have right hand side as exponent. It means that what power we will raise this 4 to have the value 16, that is 2, isn't it? If I write, suppose 3 cube is equal to 27. So again we write log base 3, result is 27. So what power will rise to 3? So have the answer 27 is 3. So whatever comes in the power, we will get it in the right side. So that's why I have written that is log is nothing but way of expressing power or exponent. So there are two logs which we generally use, that is one is known as log base 10, that is common logarithm, and second is log base e. E is a constant in mathematics, its value is 2.71, that is known as natural logarithm. So we have to deal with those. So let's start. That is log base 10. Log base 10, isn't it? So log base 10. Let's first understand what is log base 10 and then we will cover all the topics. Now again, if we write 10 to the power 1 is equal to 10. So by using log, we write log base 10. What is result? 10. And here we will have power. Now if I write nothing in log, then it will by default understood as log base 10. For example, this can be written as log 10 is equal to 1. I write nothing in the base to the log, it means that it is log to the base 10. For example, if I write 10 to the power minus 1, so this will be 1 by 10 and this is 0.1. So the result is 0.1, base is 10, power is minus 1. So we can write log base 10, result is 0.1 and here we get minus 1. Are you getting? Power is minus 1, power is minus 1. Suppose if I write 10 to the power 0 is equal to 1, implies that log base 10, result is 1 and the power is 0. If I write 10 to the power minus 3, so this will be 1 by 10 to the power 3. So this is 1 by 1000 and its value is 0.001. So by using log, we can write log base 10, result is 0.001 and right side the power is minus 3. So dear students, observe one thing, that whatever power you put on this 10, whatever power you put on this 10, the result is always greater than 0. That is, the result is always positive. Are you getting? No matter what power you put from minus infinity to plus infinity, this result you always get as positive value. So this result can never be negative. And now proceeding further, then this result is come after this log. This result comes after this log. So this result, what you are getting here is the argument of this log. What is argument of any function? That function corresponds to which thing? For example, here we are taking log of what? That is log 10. Here we are taking log of what number? That is log 0.1. Here we are taking log of 0.001. So these 0.001, 0.1 and 10 are the arguments of the function log, and these values are the result which can never be negative. So wherever for example, if you ask in a sophisticated calculator that is a value of log minus 10, so your calculator will give error. Why? Because this value can never be negative. Observe carefully. This value can never be negative. This result can never be negative, whatever power you put here. So what we do, we put this value in mod. We put this value in mod. This is known as modulus function, which means that this value is always positive. If you put log of minus 10, if you put log of minus 10 and you are applying this mod sign, then this will become log of 10. Are you getting? This will become log of 10. So what is mod function? It removes the negative sign and considers only the magnitude. So we have log 10 and the value is 1 because here it is power 1. So to what power this base 10 must be raised, so have the result 10, that is equal to 1. So are you getting now? Now there are some identities in this logarithm. Now suppose we have log 100 into 1000. So this will be log, after multiplying we have this value. So this will be Answer is 5. Why answer is 5? Because 10 raised to 5 is this value, isn't it? So now if I write log 100 plus log 1000, so log 100 is 2 because 10 raised to 2 is 100. Log 1000 is 3 because log base 10. So to how much power we will raise 10? That is 10 to the power 3 is 1000. That is right. So these two are getting the same result. So the identity is like this one, that is log AB is equal to log A. And now I am applying here the mod sign plus log B. So this is the identity number 1. Okay. Now the second identity goes like, second identity, if I write log 1000 divided by 10, so this will be log 100, isn't it? This 10 gets cancelled and finally we'll get this is 2 because 10 raised to 2 is 100. Now if I write log 1000 minus log 10, so log 1000 is 3, log 10 is 1, so this is 2. Again you are getting the same result. So the identity goes like log A by B. If you generalize this expression, then this will be log A minus log B. So this is the identity number 2, which is very important. Now identity number 3, if you raise, suppose we write log 100 square, so this is log 100 square means 10,000. So the answer is 4. 10 raised to 4 is, this is 10,000. Now if I write this, we put this power in the coefficient of logarithm, so we get that is 2 log 100. So this is 2 log 100 is 2. Again we are getting the same result, 4. So identity is log A to the power m is m log A. So I am expressing, I'm trying to make you understand the every identity by taking individual examples. So this is identity number 3. Whatever power you put in the in this expression, put that power before the logarithm as a coefficient and find the value of log A, isn't it? Now by using the same identity, we can have a different formula. For example, if I write log A to the power minus 1, so this will be minus 1 log A. For example, if I write log 0.1, so this can be written as log 1 by 10, and this 1 by 10 can be written as log 10 to the power minus 1. So power comes before this log and the answer is minus of log 10. So this is the answer, minus 1 into. So whatever the log 10 comes, it will come with minus sign. It is the value of log into 0.1. So these are the identities which are used in logarithm. Now next very important topic is, that is anti-log. As the name suggests, it is the anti-log. So what happens in anti-log? Suppose if I write log base 10 1000, so the answer is 3. So what happens here? The base is 10, exponent or you can say power is 3, and the result is 100, and the result is 100. Now if you take anti-log of this expression, anti-log, so what happens? From here, cancel this log, remove this log term, so you are left with only 1000, and base is 10, so base is 10 and this power is 3. So this result you will get after the anti-log. It is nothing, actually we have started the topic logarithm by this, in this way. First we have written the expression and then convert it into logarithm. So whatever we are getting here is the same from where we started this topic. So in general term, for example, if you write log, suppose you are write 10,000, not 10,000, 0.01 is equal to, this is actually minus 2, because this 0.01 can be written as 1 by 100. 1 by 100 is nothing but 10 to the power minus 2. So power is minus 2. Now taking anti-log, so what we will get here, remove the term log, so we will left with 0.01, base is 10, power is minus 2. So this is the expression, 0.01 is equal to 10 to the power minus 2. This is how we take anti-log, isn't it? Now if there are some expressions, for example, so general expression, write the general expression. What we write, if log x is equal to y, then after taking its anti-log, this x is equal to base to the power y. That's all. This is very simple, you can say. For example, if you are having a result that is, for example, let us suppose z is equal to log x plus log y, and I say that take anti-log. So remember, before taking anti-log, there must be only one log in the right hand side of the expression. First we have to convert this expression in such way that in the right hand side of this equation there is only one log. For example, we can write is log a plus log b using identity. This can be written as log xy. Now if you use anti-log, then what happens, from the right hand side of the equation this log will be removed, so we will left with xy, and base is 10, and here whatever comes is power. So 10 to the power x is equal to 10 to the power z is equal to x into y, or y can be written as 10 to the power z divided by x. The second is log base e. Log base e. E is Euler's number. E is Euler's number in maths. It is a constant. Its value is 2.71 up to 2 decimal places. So log base e is also known as natural log. Natural log written as log base e x, and this can be written as ln, and it stands for natural, that is log base x. Isn't it? Now the identities which we have defined for the log base 10, all the identities are repeated with the base e. For example, if I write log x into y, so this will be log x plus log y. If I write log x divided by y, then this will be log x minus log y. Third identity, if I write log x to the power a, then a comes before log, and this will be log x. So all the identities will be repeated. If I write log x to the power minus 1, it means that minus 1 log x. This fourth identity is byproduct of the third identity. Now again, if I wish to take that is anti-log, suppose if we write that y is equal to e to the power x, base is e, exponent is x, and result is y. So in terms of log, we can write log base e, result is y, and right hand side we have the exponent, isn't it? So how can we take anti-log? Suppose if I write y is equal to log x, and we are taking anti-log. So what anti-log does, from right hand side only x will be left, this log will get removed, and left hand side what happens, the base of this log is e and this power is y, so the expression becomes e to the power y is equal to x, because the another side of logarithm expression is exponent, and this is, since this is natural log, so its base is e, so e to the power y is equal to x. In this way, suppose if the expression is given as p is equal to log q plus log r, if I wish to take anti-log, so the very first step is, instead of these two logs, there must be only one log in the right hand side of the expression. So this can be rewritten as log by using identity q plus r. This can be written as log q into r. Now there is one log in one side, and another side this is power, and this is ln means log to the base e, and this qr is the result. So if I take anti-log, so taking anti-log, what happens, from right hand side only qr will be left because this is the result, and base is e and this is power. So in this way. Now, dear students, there is one relation as well in between log 10 and log to the base e. Suppose log base e x is given by 2.303 log x. So this is the relation between the two, or you can say conversion factor is 2.303. So if I write log 2, the value of log 2 is 0.301. Since this is base 10, now if I wish to find log base 2, I mean log base e, that is ln, natural log 2, then we can find 2.303 log 2 using this formula. So we have 2.303 multiplied by log 2 is 0.301, and the final expression is 0.693, isn't it? So log 1 by 2. So this can be written as log 2 to the power minus 1. So using identity, this minus and log 2, and as we know log 2 is 0.693, so the answer is 0.693, isn't it? So in series there are two series which we have to understand. The first is arithmetic progression, that is known as AP, arithmetic progression, AP. So in AP we have, suppose any sequence like 2, 4, 6, 8, 10. For example, this is 1, 5, 9, 13. For example, this is, let us have one more example, -6, 0, 6, 12. So what is common in these three series? That their common difference is same. For example, if you observe this one, here the common difference is +2, +2, +2, +2. Matlab you will get the next term if you add the +2 in the previous term. So the common difference here is, that common difference is represented by 2. Here the common difference is 4, and here the common difference is 6. Are you getting? So in general we can write any arithmetic progression series can be written as a plus d. Now again this d is common difference. Again, to get the next term we will add this common difference to this term, so this will be a plus 2d. So again, to get the next term we will add common difference to this term, so this will become a plus 3d, and in this way. So the sum of its, suppose there are n terms. How many terms? Suppose there are n terms, then sum of first n terms is given by, this is important, sum of first n terms is equal to n by 2 2a plus n minus 1 d, where n is the number of terms, a is the first term, d is the common difference. Now second series we have to understand is geometric progression, that is GP. Hai na? A series that is 2, 4, 8, 16, 32. So if you divide the second term by first term, if you divide the third term by second term, if you divide the fourth term by third term, you will get the same result, that is 2. So here this 2 is known as common ratio represented by R. In AP we have the common difference represented by small d. In GP we have the common ratio. So sum of first n terms is given by a 1 minus r to the power n by 1 minus r, provided r is not equal to 1. So here we in physics the special case of this geometric progression is used in the two chapters. The chapter electrostatic, that is electric charges and fields, electrostatic potential, and the second chapter is gravitation. So particularly in these two chapters the special case of this geometric progression is used. And what is that special case? Condition for the special case is condition. So r mod value must be less than 1, that is the value of r is in between -1 and +1, and its magnitude is less than +1. Okay. And the second condition is there are number of terms is infinite. So this formula reduces to Sn is equal to a by 1 minus r. So this is very important relation. This is very important relation. Now the question which is asked in those chapter is example question that unit masses are placed on the x-axis at locations x is equal to 1 meter, 2 meter, 4 meter, 8 meter, etc. Find gravitational potential at the origin. So the question is now question is like this, that is now here it is the origin, here it is the origin, and the masses are placed, unit masses are placed in x is equal to 1, x is equal to 2, x is equal to 4, and this way, etc. This etc means 8, 16, 32. The masses are placed up to infinite. 8, 16, 32, 64, 128, 256, up to the infinite number of masses are there. Okay. So its solution will be like that. So what is the formula for gravitational potential? It is minus gm by r, where m is the mass of the object. So mass is having value 1 kg. Unit masses are placed, it is given in the question. So the value of each mass is 1 kg. So the net potential in the origin O is given by minus gm by r. So the distance is 1 meter. Then minus gm, m is same for all the masses, that is 1 kg. This capital G is universal gravitational constant. This distance will become 2. This is minus gm by 4 minus gm by 8, and in this way up to infinity. So what are the take minus g, and this m is 1 kg. Now within the bracket you will left with 1 by 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 up to infinity. Now in this forms the geometric progression with a special case. So here r is second term by first term is 1 by 2. Now both the conditions are satisfied for a special case, that magnitude of r, that is here r is having equal to 1 by 2, which is less than 1, and the second case is the series goes to infinity. So here the series goes to infinity, so we can use the direct formula, that is sum of infinite value. And what is that formula? That is a by 1 minus r. So here we will get the gravitational potential as minus g, and the sum of the terms of within the bracket is given by a by 1 minus r. So here a is the first term, that is 1, and 1 minus r. So 1 minus r is 1 by 2. So 1 minus 1 by 2 is 1 by 2. That will become 2. 1 by 1 by 2 is 2. The final answer is minus 2g. Now substitute this value of g, that is 6.67 into 10 power minus 11. So on solving this you can get the value of gravitational potential. So this is how the geometric progression series is used. Now the second next topic is, that is binomial theorem. Portion we will deal only that portion of the binomial theorem which will be useful in physics. So the condition is the value of x is greater than minus 1 and less than 1. So here we have the formula 1 plus x to the power n is 1 plus nx plus n minus 1 x square by 2 factorial plus n minus 1 n minus 2 x cubed by 3 factorial plus so on. So what happened? what is this factorial? This 2 factorial is nothing but 2 into 1. 3 factorial is 3 into 2 into 1. Next term will be n minus 1, n minus 2, n minus 3, x to the power 4 by 4 factorial. And 4 factorial is 4 into 3 into 2 into 1. So particular formula you have to use in physics is where the value of x mod x is very less than 1. So what in such cases what happened? These higher terms x square, x cube actually can be neglected and they will only left with 1 plus x to the power n is equal to 1 plus n x. So this is how we use the formula, and the remaining terms become very much less. So this can be neglected and you will only left with the first two term, that is 1 plus n x. So let us suppose you have to find the for example 1001 to the power 1 by 3. So this can be written as 1000 plus 1 to the power 1 by 3. So this can be written as 1000 1 plus 1 by 1000 whole to the power 1 by 3. Now this 1000 multiplied by 1 plus 1 by 1000. So this 1 by 3 will come to the both terms. So this will be 1000 to the power 1 by 3 and 1 plus 1 by 1000 to the power 1 by 3. So this 1000 can be written as 10 cube to the power 1 by 3. And observe carefully. Now this is in the format of binomial theorem special case, that is 1 plus x to the power n, where this x is 1 by 1000, which is very less than 1. This is a 1000th part of 1. So we can use the special case of binomial theorem. That is, this can be written as 1 plus, in place of n we have 1 by 3 and in place of x we have 1 by 1000. And here this two powers will get multiplied, so 3 gets cancelled and here we get 10, and this is 1 plus 1 by 3000. Now this is 1 by 3000, so this will be 0.00. 1 by 3 is 0.3 divided by 1000, that is 0.003. So this will be 10 multiplied by 1.0003 and just its value is 10.003. So this is the answer. This is how we use apply binomial theorem. But the condition must be satisfied, that is the second term must be less than 1. Only then we can use the binomial theorem. Now in gravitation chapter, when we find the expression of gravity, value of gravity, or you can say variation of the value of acceleration due to gravity with height, then we have the expression there, that is gh, that is value of acceleration due to gravity at some height, is given by g r square by r plus h square. Now this is the expression. Now in particular case, for example, when the value of height is very less than radius of the earth, here the r is the radius of the earth, the small g is the acceleration due to gravity at the surface of the earth. This is the second application of the binomial theorem, isn't it? So what we do, this term can be written as, observe carefully, this can be written as g r square, and from here in this expression I take r outside the bracket, inside the bracket we are left with 1 by r square and whole to the power square. This is square. If you open the bracket you will get the same result, that is r plus h by r gets cancelled and you will left with h. Now this square g r square, this power comes r square, and this will be 1 plus h by r square. This r square gets cancelled and you will left with gh is equal to g, and this is 1 plus h by r power 1 by 2. Now observe carefully, the value of h is very less than r. So what happened, the value of h by r will be very less than 1. It means that what we get, if you divide the two sides of equation with r, you will get h by r very less than 1. So it is satisfying the condition of a special case of binomial theorem, that is the second term h by r is very less than 1. So we can use the formula 1 plus x to the power n is equal to 1 plus nx. So apply the formula, that is gh is equal to g 1 plus, in terms of n we have minus 2, so minus 2, and in place of x we have h by r. So the formula is gh is equal to g 1 minus 2h by r. So this is the formula of acceleration due to gravity at some height h, provided the height h is very less than r. So this is the application of binomial theorem. Now next, modulus function. What happens, dear students? It is a very rarely, its question rarely comes in NEET physics, but still it has some chances, and this actually corresponds to the kinematics chapter, motion in a straight line, where we will deal with such kinds of question where the modulus function is being used. So let us first understand the modulus function. What happens? Suppose if I write y is equal to mod of x. So what happens? I am writing here x and here I am writing y is equal to mod x. So we have different values here. Suppose x is equal to minus 1, then its mod value is plus 1. Suppose x is equal to 0, so its mod is 0. Suppose x is 1, so y is again mod x 1. Suppose x is minus 2, so mod of minus 2 is 2. So what is modulus function? If you put mod, for example, if you put mod of minus 2, then it consider only magnitude, you will left with 2. It has nothing to do with the sign, it just removes the sign and only magnitude is considered. So are you getting? So what are the things you are observing here? That if you observe carefully, then y is equal to x. Y is equal to x. कब हो रहा है? When y is equal to x. When it does happen? When x is greater than or equal to 0. For x is greater than or equal to 0. Observe carefully. If you put x is equal to 2, you get y is equal to 2. That is y is equal to x. If you put x is equal to 1, you get y is equal to 1. If you put x is equal to 0, y is equal to 0. But the condition is x must be greater than or equal to 0. But what happens for values less than 0? For example, if you put x is equal to minus 1, then y becomes equal to plus 1. So you can write y is equal to minus x for x is less than 0. Observe carefully. X is equal to minus 1, then y is equal to minus of minus 1, that is plus 1, that is y is equal to minus x. If you put x is equal to minus 2, then y is equal to minus of minus 2, that is plus 2. So y is equal to minus x for x is less than 0. So what happens? This mod function gets converted into two separate equations. This is the logic behind this modulus function. So whenever in question you are given a condition of velocity or something like that, in single equation modulus function, then you have to convert that equation into independent equations. For example, suppose velocity of any particle is given as 4t minus 2. So dear students, directly you have to form two different equations, and the procedure to form the two different equations is, first we have to find the value of t for which this equation reduces to 0. So from here we get t is equal to 0.5. Now it is very clear from this expression that if the value of t is less than 0.5, then this value is positive. So I am writing if, or you can write for t greater than 0.5, 4t minus 2 is equal to positive. It means that, what does it mean? It means that v is equal to 4t minus 2 for t is greater than 0.5. So the first equation is formed. Now second is, first of all what we have done now, remember carefully that we have find the boundary condition or the value of t at which this equation reduces to 0. Now second, we are damn sure that if you put value less than 0.5, then this expression becomes negative. That is, for t less than 0.5, this 4t minus 2 is equal to negative. But what happens? What happens? You are applying mod here. It means that if the value comes negative also, it doesn't matter, because if you apply mod sign, then finally you will have the expression of v as positive. So v is 4t minus 2. So this is equal to, observe carefully, this 4t minus 2 is negative. And you know that mod of 40 minus 2 is positive. Then how is it possible if you apply minus in this 40 minus 2 for t less than 0.5? If t is less than 0.5, then this value becomes negative, and this negative multiplied by negative becomes positive, and this is equal to 40 minus 2. Why? Because modulus function can never be negative. So this is the way. So the second equation is minus of 40 minus 2 for t is less than 0.5. So this is the way you can use modulus function. There you can take many more examples. For example, if any position of any particle is given as 3t minus 6 mod. So you have to form two equations. The procedure is, the first step 1 is put 3t minus 6 is equal to 0. So from here you will get t is equal to 2 seconds. It means that the value of 3t minus 6 is equal to positive for t greater than 2 seconds. So y is equal to 3t minus 6 because it is already positive for t is greater than 2 seconds. So this is equation number 1. Ready? Second equation, what happens? This 3t minus 6 will be negative for t less than 2 seconds. So to make it positive, we must apply minus sign before this expression 3t minus 6. So y will become equal to minus of 3t minus 6 for t less than 2 seconds. Because y is equal to mod of 3t minus 6, and if it's negative value or mod of 3t minus 6, and if 3t minus 6 is negative, then to make it positive, multiply it by minus sign, because modulus function can never be negative. So this is the procedure of forming the two mod functions. Now next is squares and square roots. So dear students, first of all, if you are a serious NEET aspirant and you will have to crack that exam, then you must remember the squares of numbers at least up to 25. And if you don't remember, then don't get panic. I am giving you a trick so that any square of any number you can find very easily. For example, if you wish to find, just observe the trick I am applying here. Suppose you wish to find 22 square. So what you need to do is take the square of unit place, that is 4. Then multiply these numbers 2 into 2 into 2. So 2 2s are 4, 4 2s are 8. And then take the square of this 10th digit, that is 2 square, 4, 484. So you can learn this method by observing the various examples which I am giving here. For example, you will need to find suppose 25 square. So 5 square is 25. Listen, 5 square is 25. Unit place square 25. So write the unit digit 5 square. Carry 2. Now second step, 2 into 5 into 2. 2 5s are 10, 10 2s are 20. Plus carry what we are obtained in the step number 1. That is 20 plus 2 is 22. Again carry 2. So the last step is 2 square 4 and 4 plus 2 is 6. Suppose you need to find 18 square. First step, 8 square is 64. Carry 6. Second step, 1 into 8, 8 into 2, that is 16. 16 plus 6, carry 22. Again carry 2. Now the last step, 1 square 1 plus 2, 3. Next example, suppose 33 square. So 3 square is 9. Then 3 into 3 into 2. 3 3s are 9, 9 2s are 18. Carry 1. So 3 square 9, 9 plus 1, 10. 1089. 42 square. 2 square is 4. 4 2s are 8, 8 2s are 16. Carry 1. 4 square 16 plus 1, 17. Let's have some bigger number. For example, 56 square. 6 square 36. Write unit place 6. Carry 3. Add this 3 to the second step, that is 5 into 6, 30, 30 to the 60. 60 plus 3, right, unit place, 63. Again carry 6. Add this 6 to the last step, that is 5 square 25 plus 6, 31. Suppose 63 square, 3 square. So first we have to prepare the unit place of the answer, that is 3 square is 9. No carry in this case. Second step, 6 into 3, 18, 18 to the 36, 36. Right unit place, that is 6, carry 3. Add this 3 to the square of the 6, that is 6 square 36 plus 3, 39. Have some more examples so that it will be very clear to you. 17 square, 7 square 49, right unit place 49, 9. Carry 4. Now 1 into 7 into 2, 14, 14 plus 4, 18, right unit place, carry 1. 1 square 1 plus 1, 2, 289. So in this way, now if you have any doubt, you can comment on the comment box. Okay, now next. Now come to the square root. Now there is also a method of finding a square root. So first of all, you have to remember root 2 is equal to, that is 1.414. Root 3 is equal to 1.732, isn't it? Now suppose you have to find approximately, I'm giving the trick to find the approximate value of the any root. Any root. For example, you have the expression root 39. You have to find root 39. So observe the method, solving various examples. You are able to understand the method which I am adopting now. So observe carefully. Root 36 and root 49. Now observe the perfect square. Just before this number is root 36 is equal to 6, and just after this number is root 49 is equal to 7. It means that the value of root 39 must lie between 6 and 7. Very common sense. Now the second step is observe the difference of these two numbers, that is 36 and 49. The difference is 13. The difference is 13. So what happens if you wish to find root 37? This can be root 36 plus 1 by 13. If you wish to find root 38, then this will be root 36 plus 2 by 13. If you wish to find root 39, then this will be root 36 plus 3 by 13. So this is how you get the value. This is 6 plus 3 by 13 is 0.22643. So this approximately you will get 6.23. Similarly, suppose for example you need to find root 27. So what you do, this is root 25 is equal to 5, and just after it is root 36 is equal to 6. The difference between the two is 11. So if you wish to find root 26, then this will be root 25, that is 5 plus 1 by 11. If you wish to find root 27, then this will be 5 plus 2 by 11. In this way, root 28, 5 plus 3 by 11. So this will be 5 plus, this will be 0.11 ones are 11, 9, 8. So this is approximately 5.2. So this is value. This is how you can find that. So first you have to take the difference and then divide that difference by 1. I mean 1 by, for example, here we are having 1 by 11, 2 by 11, 3 by 11. So in this way, when you move finally root 36, you will have the 11 by 11, that is 1. It will become 6. For example, again, let us suppose we wish to find root 18. So this can be, what is root 16? Root 16 is 4, and just after root 18 is root 25 is 5. The difference between the two is 9. So how can you find root 18? So what is root 17? That is 4 plus 1 by 9. What is root 18? That is 4 plus 2 by 9. So finally we'll get 2 by 9. If you solve this, so 0.9 to the 18, 2. So this will nearly equal to 4.22. So this is how you can have the approximate value of this. So the second chapter is trigonometry. So we will deal the trigonometry in the upcoming lecture. So that's all for this lecture, dear students. Thank you.